Okay, so for this first one, which one of those two is the cation? How do you know the hydrogen's the cation? How do you know it's got a +1 charge? Nope. Because it what?
It's with the non.
So in the notes, wasn't it the positive was metals and negative was ions?
Non-metals.
Hydrogen with a non-metal has a +1 charge. There are no exceptions to that. What's another way to determine that this hydrogen's got a +1 charge? Fluorine is got a -1 charge no matter what. So that automatically makes the hydrogen a +1 charge. So I got a hydrogen with a plus, and I got a fluorine with a minus. And what's the name of this guy? Hydrofluoric acid. It's, if anybody put hydrogen fluoride, negative, it's hydrofluoric acid. How did you know that you were supposed to name it as an acid? It began with an H. Okay. How about the next one? Which one's positive, which one's negative? The calcium one's positive, how come? Because it's calcium, right? So when a metal goes into a compound, what does it do with its electrons? It gives them away. Those are the only options. It's as itself, having all of its protons and electrons as an atom, and then it becomes a compound, and during the course of becoming a compound, it gives those electrons away. So the only possible charge for a metal is going to be 0 if it's by itself, or positive if it's in a compound. And if you look on those list of rules, group 2 is +2 charge. Okay, so I got a calcium with a +2 charge, and then that makes my oxygen automatically have to be a -2. And the name of this? Do I need to say calcium 2 oxide? I do not. Why do I not? Calcium only has one possibility, one oxidation state, and that's +2. Okay. All right, so I got a, who gets to be my cation? My cadmium, okay. And what's its charge? +2. That doesn't really look like a 2. And that makes my bromine my anion and negatively charged. And so then this is, dang it. So cadmium bromide. Why not cadmium 2? Only has the +2 charge. Even though it's one of the transition metals, it's one of those 3 transition metals that has a fixed oxidation state. So we don't give it a name with a Roman numeral. All right, so positive charge in number 4. Hydrogen, bunch of non-metals. All right. So hydrogen with a plus charge. Is that it? Is that right? Yeah, that's right. Are we okay with the phosphorus being a +5? If each of the oxygens is a -2, that gives us -8, and then I can cancel 3 of those out with my hydrogen, so that leaves me with a -5. And since this has no overall charge, the phosphorus must be the other, managing the other 5 positive charges. And the name of this? Phosphoric acid, because PO4 is phosphate. Okay, cation and anion for number 5. How do you know the oxygen's -2? It's almost always -2. So how do we know that this time it is -2? Do we have a rule for the bromine, the halogen bromine? What's the halogen rule?
-1.
Unless, and here's the important part, it would be -1, except with oxygen or a halogen higher on the list. And oxygen, obviously, gets to do what it wants to do with the halogens except for fluorine. So if the oxygen's a -2, and this, what is the name of this thing? Bromide. This is the polyatomic ion bromide. So if oxygen is -2 and this bromide has a -1 charge, what does that leave for the bromine's charge? What are you doing? -2? +2, okay, yeah, +2. So if my bromine's a +2 and my oxygens are -2, -2, that leaves me with a leftover -1, which is what I need for a bromide. Okay, the next one?
I have
Who's?
a question about that.
Absolutely.
So, how can bromine be 2 if it's not an option?
Those are common options.
Oh, so even if it's not on there?
You shouldn't really look at those non-metal oxidation states. They're very not super helpful. There's no reason that Flynn should have listed, what is it, 3 or 5 different oxidation states for chlorine and bromine, because many of those aren't common, and bromide isn't a completely uncommon ion, so the bromine does have a +2, so why it's not on that list, I'm not really sure. So just because that thing there, that's not like be all end all. So who's my positive charge in number 6? Copper. And what's copper's charge in this case? How do you know that copper is a +2? Because the halogen, chlorine is a halogen, and it says that the chlorines are -1 unless they're with oxygen or another halogen, and copper is not a halogen or oxygen, so -1 makes that copper a +2. And so what do we want to go with for a name for this guy? Are we okay with copper 2 chloride? I have to put the 2 down there because copper can have a +1 charge. So you need to tell me which one it is, or I need to be told which one it is. Cations for number 7. The sodium's a positive charge. The hydrogen is a positive charge. The oxygen is a -2 charge. And that leaves me with a carbon that's got a +4 charge. A name for this one?
Sodium hydrogen.
Yep. The more common name for this, or a common name for this, is sodium bicarbonate. Baking soda, super common name. The one thing we want to talk about with this one is the hydrogen rule says hydrogens are +1 if they're with a nonmetal and -1 if they're with a metal. How do you know that that hydrogen gets to be a +1 charge?
It's with nonmetals.
Well, sodium's a metal.
I know, but carbonate is HCO3.
Yeah, it's not really with it, right? This hydrogen isn't technically with the sodium. This hydrogen is with this carbonate, and this hydrogen carbonate is with the sodium. It makes a world of difference. When this thing goes into water, it dissolves, the sodium pops off, the hydrogen goes with the carbonate. It doesn't go off with the sodium. So this is a thing, hydrogen carbonate, that's one of the polyatomic ions you need to know, unto itself. So that hydrogen is with the carbon and with the oxygen, not with the sodium. All right, how about a formula for the next one, the silicon dioxide?
SiO2.
Yep. SiO2. Okay. And you don't have a silicon rule, but you have an oxygen rule, so that's going to be a -2 charge. And then that makes my silicon a +4 charge. So I've got dinitrogen pentsulfide. So what's the formula here? N2S5. Okay. And my sulfur is going to be a -2. And then that makes my nitrogen a +5. Oops, I didn't know that right. N +5, S -2. Ammonium dichromate, what do we have for a formula for that one?
So it's NH4 CO2.
Okay. Are we all right with that?
Where's the O2?
It's a 7.
That's a 7.
Why is there 2 ammoniums?
Because the charge on dichromate is -2.
Right.
The oxygens are a -2 charge. The nitrogen is a -3 charge. The hydrogen's a +1 charge. And that makes my chromium a +6 charge.
Is the ammonium in parentheses?
Uh-huh. Because there are 2 NH4s. Hydroxide? So my hydrogen is a +1, my oxygen is a -2, and I'm done. Mercury 2 iodide, what's that formula?
Maybe HG.
And the mercury is positively charged with a +2 charge, right? Because we were told. And so then the iodines are each a -1 charge. And zinc fluoride. Zinc, that doesn't look very good. Do you have questions about any of these?
With the mercury one, if the 2 is saying that there's 2 mercuries, why wouldn't
It's
the-
not saying that there's 2 mercuries. It's saying that the charge is +2.
Okay. So, okay.
So the only time you have to write the Roman numerals is if you're going from the formula to the name.
Yeah. So when you're looking at this, you have this mercury, and so what we have is this portion of this name is saying you have an Hg with a +2 charge. That's what that mercury 2 is telling you. And then this over here is saying you have an iodide, and the iodide's charges are -1. So then you put them together so their charges cancel.
Okay, so that's why the 2, when you write the compound name, has a 2 after the iodine, because you have to have 2 of the negative. Since iodine is -1, you have to have 2 of those. Okay.
Exactly. Okay. HBr? Hydrobromic. And then hydrofluoric? Just HF? How about H2CO3? Yep, carbonic. And phosphoric, what's that one? H3PO4? How about the next one? Acetic acid? What's that formula?
Let's see.
It's an acetate, that's CHCOO, and then you tack an H onto the end of it. The next one? So how does this one and the first one, how do they differ? One's got oxygen in it, so I just say bromic acid with that one. And then the last one, perchloric. Okay. What's the first thing you should look for when you're trying to write the name for a chemical formula? Okay. Is it start with an H? That's one thing. What else?
An ionic.
Is it ionic? And if I'm looking for ionic, it will be ionic if there's a metal there, or one of the polyatomics. So if it doesn't start with an H and there isn't a metal or a polyatomic ion there, then I name it covalently. Starts with an H, name it like an acid. Metal, polyatomic ion, name it for an ionic. None of those things, then name it covalently. How do you know if a compound's ionic or covalent? It's got a metal in it. 99.9999% of the time it's ionic because there's a metal there. Is there an exception to that? Yeah. NH4, that positive charge could be the cation for the ionic compound. So something like NH4Cl. Are there any metals there? Nope. Is there a polyatomic ion there? Yep. So it's an ionic compound. And since we're here, there's another name for ionic compounds. Does anybody know what that is?
Binary.
It's a salt. All ionic compounds are salts. Not just the one that you know most commonly, which is NaCl, but every single ionic compound, the other name for an ionic compound is a salt. So if I look up here at this list, number 2 is a salt. Number 3 is a salt. Number 6 is a salt. Number 7 is a salt. Number 10 is a salt. Number 12 is a salt. And so is number 13. There are a great deal of salts in the world. I just don't want you to think salt and think salty, because when you're thinking about salty, that's really the incorrect way to say that. When you taste table salt, what is it that you're tasting? Sodium. You're tasting that metal. You're tasting sodium. So table salt tastes sodium-y, not salty, because I could give you a whole bunch of salts and they would not taste sodium-y to you. So does anybody use Epsom salt for anything?